Good day everyone, welcome back again. This video is about special types of algebraic function. Now we'll be talking about, we have here constant function, identity function, absolute function, greatest integer value function, piecewise function, and of course the signum function. Okay, so without further ado, let's start. Okay, so for the first one, we have there the constant function. So example of a constant function is y is equal to a, where a is a constant. So if you want to draw the graph of a constant function, suppose we have y is equal to 1, okay? So y is equal to 1 is an example of a constant function. Why? Because if we construct the table of values, suppose we have here x and y, if we construct the table of values, since this is a constant function, for whatever value of x, your value of y is always constant. So for this case, if your x is -3, your y is 1, diba? If your x is -2, your y is still 1. For whatever value of x, your y is always equal to 1. That is because this function is a constant function. Now, if you want to draw the graph of a constant function, okay, you just need to plot these points. So we have these points. And if we identify more points, it would look like this. Okay, and if you connect these points, these dots, your graph will look like this. And this one is the graph of y is equal to 1. This is an example of a constant function. Now, it is also important, since we are in this topic naman, it is also important that you should know how to identify the domain and range. And I think this is just very easy because we already have here the graph of the function. So to find the domain and range, okay, let's find first the domain. Take note the domain is the set. It is the set of all permissible values of x. Now, since the behavior of the graph, this is horizontal, and we have arrow here, and we also have arrow here, and that means that this line would just go on forever to the left, and it would just go on forever to the right. So that means that all of the x along the x-axis from the -infinity to the positive infinity would be covered by this line. Okay, that's why your domain should be all real number. So you would write your domain is, okay, yan. So that is your domain. How about the range? So how do we determine the range? Now look at the line. Take note that the range is the set of all possible values of y. Now, since if you look at the graph, the only possible values for y is 1, and there are no other possible values. So your range would be, if you write your range, it would be y such that y is equal to 1. That's it. That's your range. Okay? Next naman, we have this identity function. Okay, so what is an identity function? An identity function, it's actually, we have here an example. That is y is equal to x. So let us try to find out why it's called identity. Okay, if you want to draw the graph, we have here the Cartesian plane, the x and y axis. Okay, and if you want to draw the graph, you just need to construct the table of values. So we have here x and y. Okay, so magko-construct tayo ng table of values. Okay, let's start at -3. So if we have -3 for x, your value for y is, when you substitute -3 to this equation, your value for y is still -3, diba? Now look at the values of x and y. They are the same. That's why it's called identity. This type of function is called identity function, because for whatever value of x, that's exactly the value of y. So for example, if you have -2 here, your y is also -2. If you have 2, this is also 2, and 3, this is also 3, and so on and so forth. Okay, and if you want to draw the graph, you just need to plot these points. So we have these points. And if you connect these dots, these black dots, and this one is the behavior of the graph naman. So this is your y is equal to x. Now to find for the domain and range of this function, now this is just very easy, because if you look at this, at the graph, diba? This graph would just go on forever on this direction, upward to the left, upward to the right, and this one, this will just go on forever, downward to the left. Okay, now if you look at the x-axis, for the x-axis, all of the number in the x-axis would be covered by the graph, diba? That's from the negative infinity to the positive infinity. That's why your domain is also all real number. The same with your range, because if you look at it, all of the values in the y-axis will also be covered by this function. I mean, by the graph of this function. And also, if you can still remember, this type of function is actually an algebraic function. I mean, a polynomial function. Diba? As you have learned on the previous video, when you are dealing with a polynomial function, you just need to look at the highest exponent of the polynomial. Okay, if it is odd, then the domain and range for that function is all real number. And true enough, since the highest exponent is 1, that's odd, then the domain and range for this function is all real number. Okay. Next one, we have the absolute value function. Okay, so we have here the Cartesian plane also. And if you want to draw the graph of this function, of course, you have to construct first the table of values. So you have your x and y. Okay, now let's start when x is negative 3. What's the value of y? You just need to plug in negative 3 to this equation to find for the value of y. So when this is negative 3, when x is negative 3, your value for y is positive 3. Okay. How about if this is negative 2? When you substitute it here, the value is positive 2. Now, if this is negative 1, this is 1. If this is 0, 0. If this is 1, 1. If this is 2, this is also 2. Okay? So these are the points on the graph of this type of function, the absolute value function. Okay, if you plot these points, it would look like this, small dotted points. And if you connect these points, it would look like this. Now, these two lines that seem to form a V shape, that's the behavior of the graph of y is equal to the absolute value of x. Now, the next thing you need to do is to find for the domain and range of this function. Now, this is just very easy because you already have the graph. Okay? Okay, let us try to solve for the domain. The domain. Okay, take note, the domain is the set of all permissible values of x. Now, when you look at this graph, okay, this arrow here will just go on forever upward to the left, and this will go on forever upward to the right. Okay, to the right, and this one is to the left. So that means that all of the values of x on the x-axis will be covered by this function. Okay, so that means that your domain is also all real number. Okay, so this is x such that x is all real number. How about the range? How do we solve for the value of the range? Look at the graph. Okay, now take note that the range is the set of all possible values of y. When you look at the graph, okay, the graph is from the x-axis upward. There are no points that can be found on the graph that are below the x-axis. Okay, so that means that your range is actually y such that y is a real number, but it is your y is greater than or equal to 0. Diba? This is the minimum value of your y kasi, di ba? This is your minimum value of your y. Okay, then upward. It would be impossible for this function to generate a negative value for y. That's why your range is y such that y is all real number, but it is greater than or equal to 0. Okay, so that's the absolute value function. Okay, let us have another example. Suppose we have here y is equal to x plus 1. Okay, so how do we evaluate this one? Of course, you first have to construct the table of values. So we have your x and y. Okay, so when your x is negative 3, you just need to substitute it here. So negative 3 plus 1, that is negative 2. Absolute value of negative 2, that is 2. So this is 2. Okay, and this is negative 2. Just need to substitute again. Negative 2 plus 1, that is negative 1. Then absolute value of negative 1, this is 1. Okay, so this is negative 1, and this is 0. Okay, so this is 1, this is 2. This is 2, and this is 3. Okay, and so on and so forth. So these are the points that can be found on this absolute value function. This y is equal to the absolute value of x plus 1. Now, if you plot this one, so we have here negative 3, 2, 2, 1. We have here negative 1, 0, and so on and so forth. Okay, and if you connect these dots, it would look like this. Okay, so this one right here, this V-shaped arrows, is actually the graph of the function y is equal to the absolute value of x plus 1. Now, how do we find for the domain and range again? Your domain will be, okay, this is all real number also, since all the values of x will be covered by the graph. So this is x such that x is all real number. How about the range? Okay, the range is still the same from the previous example because the lowest value for y is also 0. So this is y such that y is all real number, but y should be greater than or equal to 0. Yan. That is the domain and range of the absolute value function. Y is equal to the absolute value of x plus 1. Next, we have this, the greatest integer value. Okay, we have here an example. Y is equal to some sort of double bracket, and inside of that sign is x. Okay, so we have here the double bracket, and inside of that sign is x. Okay, so what is the greatest integer value? Okay, this function, it outputs value which is the greatest integer that is lesser than or equal to x. Does that make sense? Okay. Output values which is the greatest integer that is lesser than or equal to x. For example, okay, suppose okay, let us try to construct the table of values. So we have our x and y. Okay, suppose we have, say, for example, say 1.2. Okay, so it says here, this function, it outputs value which is the greatest integer that is just lesser than or equal to x. So this is your x. This is your x. So 1.2, that is your x. The greatest integer that is just lesser than or equal to this value. Okay. Okay, wait lang. Because for 1.2, okay, if we draw the line kasi, if this is 1.2, okay, ani din probably yung 1, and this is 0, and we have here the negative 1. Okay, so for 1.2, there are many integer that are lower than 1.2. Diba? There are 1, there is 0, there is negative 1. Okay, ang hinahanap lang natin out of those infinite number that is lesser than 1.2 is the greatest, and that is 1. Right here. Okay? So yung output mo dito is 1. Okay. Okay, suppose we have 1.3. Ano ba yung lesser value integer sa 1.3? But that is 1. Okay, suppose we have 2.4. Oh, your output for y is 2 because the greatest integer that is just below 2.4 is 2. Okay? Okay, suppose we have say 5.0. Oh, ano yung output mo sa y? Of course, that is 5.0. Take note ha, it outputs value which is the greatest integer that is just lesser than or equal to x. Lesser than or equal to x. Okay, so for this one, 2.4, the lesser value is 2. And 2 happens also the highest, the greatest integer that is just below 2.4. That's why your output for y is 2. Okay? Okay. Let's try to erase first. Okay. Let's try to draw the graph. Okay, suppose we have here the rectangular coordinate system. Okay. So for this function, the graph of this function would look like this. Okay, let me explain. For this function, suppose we have a value of x at say 1.5, diba? Ang ihahatag niya na value for y is 1 because 1.5, the highest integer that is just below 1.5 is 1. So ang ihahatag niya is 1. So that means that for this region of x's, the value for y is this one, 1. Okay? And that includes 1. That exclude, hindi kasama, yung 2. Because when you give x, when you let x be equal to 2, ang value na is 2. Here. Okay. And here. So that's how your graph of this function behaves. Or this one right here. Parang ganon. That's how your graph, that's how the graph of this function behaves. Okay, let me just erase this one. Now, this is the graph of the function y is equal to double bracket x. Okay, we call this function as the greatest integer value. The greatest integer value function outputs values which is the greatest integer that is also just lesser than or equal to x. Okay, suppose we have this one. Okay, so how do we draw the graph for this type of function, for this function? Okay, suppose, of course, we have to to construct the table of values. Okay, let's start at when x is negative 3. So you just need to substitute negative 3 here. Okay, negative 3 minus 1, that is negative 4. So this is negative 4. Ganon. Okay, since this is negative 4, your output here is negative 4. Okay, because the greatest integer that is just lesser than or equal to whatever is inside that bracket, that double bracket, is negative 4. Okay, suppose we have here, suppose we have negative, say, 2.5. 2.5. We have negative 2.5. When you substitute it here, okay, so let me just erase this one. So negative 2.5 minus 1, the result would be negative 2.5 minus 1, that is negative 3.5. Ganon, negative 3.5. O ano naman yung value ng y mo? Okay, so you have here negative 3.5 inside the bracket. So what will be your value for y? Take note ha, what we are looking for is the greatest value that is just below 3.5. What integer is just below 3.5? That is negative 4, right? Negative 4, because if you have this number line, if you have here 4, if you have here 3, and you have here 3.5, negative, this is negative 3.5. So the highest integer that is just below 3.5 is 4. Below 3.5 is 4. 4 is also the highest integer that is just below negative 3.5. So your input here, your output here is negative 4. Okay, suppose we have negative 2. Okay, substitute here, then the value will be negative 2 minus 1, that is negative 3. Okay, and this is negative 3. Okay, how about negative 1.5? I'm pretty sure this is also negative 3. Okay, for 1, negative 1, that is negative 2. Now, can you see the pattern? Okay, now if we plot the graph of this integer, of this function, it would look like this. Okay, for negative 3, the value is negative 4. So we have to add here negative 3 and negative 4. Somewhere here. Okay, solid dot. 2 here, This one right here, open dot, meaning negative 2 is no longer included in this line. Okay, open dot, solid dot. Okay, for open dot, meaning that point, the negative 2 is no longer included on this on this line. Then the next one you have here 2, negative 2, and this is negative 3. Okay, solid dot, and you have a line, and open dot, solid dot. Yan. This is the behavior of the graph. Okay. Okay. It's a little bit messy. Let me erase this one. So this is the behavior of the graph. Now, based on this graph, we will find for the domain and range naman. Let me just erase this one. So how do we solve for the domain and range? Of course, this graph would just continue on moving forever here. Parang magsusugad-sugalit hiya. Ito, patuloy ulit hiya. Warat hiya katapusan. Walang katapusan yan. Patuloy lang yan at walang katapusan going up there and this one going down there. Okay? So, to find for the domain and range, let's talk about domain first. Okay. Take note ha, domain is the set of all possible values of x. Now, if you look on the x-axis, okay. So, for example, if your point here, if you choose this point is still covered by the graph, diba? Okay. If you choose this point right here, this point is still covered by the graph. Okay? Nakukuha? Okay. How about negative 2? Is negative 2 covered by this graph? This graph right here? Okay. Hindi siya covered because hollow siya, di ba? But covered siya ng graph na to. So meaning, negative 2 is still covered by the whole graph, by the whole y is equal to the quantity x minus 1. Okay? So basically, when you look at it, the value of the domain is actually from the negative infinity to the positive infinity. That is all real number. So your domain is x such that x is all real number. Yan. How about the range? Range. Now look at the graph. Let us look at the graph. Okay. Now we are looking for the value of the range. Take note, this is the set of all possible values of y. So for y naman, okay, if you choose this point on y, diba? This one, if you extend this line, this will not intersect on the graph of the function. Meaning, this point right here is not a possible value of y. Ay, ano man yung mga possible values of y? On here. Oh, negative 3, negative 3, negative 4, negative 3, negative 2, negative 1, 0, 1. So how do you describe the range? Of course, that is not x. That is y. Such that y, of course, is a real number. So what is the other, how would you define the range? Okay, you would define the range like this. Your y is integer. Integer. Yan. Your y is integer. Diba? Negative 4, negative 3, negative 2, 1, 0, 1, 2, 3, 4, and so on and so forth are integers. So your range would be y such that y is a real number and y is also an integer. So that's how your range, that's how you define your range. Okay. Next. Okay, so we have here piecewise function. So what is a piecewise function? Okay, let us have an example. Okay, so I have here the f of x is equal to 2x minus 1 if x is less than or equal to negative 2, and the f of x is equal to 4 if x is greater than negative 2 but less than or equal to 3, And the value of f of x is equal to negative x plus 2 when x is greater than 3. So I know some of you already encountered these in high school, this piecewise function. So what is a piecewise function? Okay, so there are 3 lines, okay? 3 lines, this one, and this one. Each line, you have a comma here, okay? The comma separates this quantity and this inequality or this condition. Actually, we call this one as the condition, and this is actually the value of the function. So it says that the value of the function is 2x plus 1 when x is less than or equal to negative 2. This first line is just a part of the function. It's just a piece of the function. And for another line, this one, it's another piece of the function. And this is another piece of the function, another part of the function. Okay? So how do we draw the graph of this function? Okay, of course, we have to construct the Cartesian plane. Okay, so let us construct the Cartesian plane. Okay, let me just erase. Suppose this is the Cartesian plane. Yan. Let's draw the graph first of the first line first. Okay, yung first line lang muna. Okay, so we have here the table of values, x and y. Okay, we're trying to understand the behavioral graph of the first line, this one. Okay, suppose when x is 0, can you do that? Pwede ba nating i-substitute 0 to x for the first line? Now look at this boundary condition, this condition right here. Now the value of the function is 2x minus 1 if your x is less than or equal to negative 2. So when your x is 0, you cannot use this value because this value is only used if your x is less than or equal to negative 2. But 0 is not equal or less than or equal to negative 2. So you cannot use 0. We will start at negative 2 because x daw is less than or equal. So that's from negative 2 paubos, less than or equal to negative 2. So we'll start at negative 2. When x is negative 2, your y is, when you substitute negative 2 here, so this will be 2 times negative 2, that's negative 4 minus 1, that is negative 5. When this is negative 3, that is negative 3 times 2, that is negative 3 times 2, negative 6 minus 1, this is negative 7. If this is negative 4 times 2, negative 8 plus 1, this is negative 9. Okay, can you see the pattern? If it is negative 5, this is negative 11, and so on and so forth. Now, if we plot these points, okay, so we have your negative 2, negative 5. 1, 2, 3, 4, 5 here. Okay? And let me emphasize this, bakit dot ang ginamit ko. Solid dot at hindi hollow dot. Bakit solid dot ang ginamit ko? That is because your negative 2, this one right here, is included. Take note ha, x is less than or equal to negative 2. Meaning, the negative 2 here is included. Okay, that's why solid dot ang ginamit ko. If the condition here is just x less than negative 2, then your dot here should be hollow. Hindi siya dapat solid. Okay? That is if your condition here is x less than negative 2. But since that is x less than or equal to negative 2, then that is a solid. Okay, next point, you have here negative 3, negative 7. So you have your negative 3 and 5, negative 5, negative 6, negative 7. So right here. Okay. And sunod, negative 4 and negative 9 naman. Right here. Okay. And so on and so forth. So if you connect these dots, parang ganun. Of course, with arrow because it's a never-ending line. and it started from this point and going down there. Okay. Bakit nag-start tayo sa negative 2? How about if we change our value of x, say negative 1? Okay. Take note that negative 1 is not less than nor equal to negative 2. Okay? Negative 1 is actually greater than negative 2. Okay? So, when you look at the condition, negative 1 would fall until the second line because negative 1 is in between negative 2 and 3. Or should I say negative 1 is greater than negative 2 but it's still less than or equal to negative 3. So, pasok ang negative 1 on the second line. Okay, so you will use the second line to solve for the value of y. And since according to the second line, the value of the function is 4. So, this is 4. Okay, for 0, this is also 4. For 1, this is also 4. For 2, this is also 4. For 3, this is also 4. Okay, and when you plot, we'll start at negative 1. This is negative 1. This is 4. 1, 2, 3, 4. Somewhere right here. But take note that your criteria here, it says that x is less than negative 2. So technically, you will start at negative 2, but negative 2 is already excluded. Okay? So when this is negative 2, this is 4, but this, negative 2 is excluded already. For the line number 2, your x would start at negative 2, but negative 2 is all excluded. So technically, you should have here a hollow dot. Ganon. So for 0, this is also 4. For 1, this is also 4. For 2, and for 3. So when you connect this line, yan. Of course, walang arrow because specific lang ang limit. Take note ha, from negative 2 to 3. So yan. Okay, paano kung gamitin natin is, if the value of x is, let me just erase. If the value of x is already 4 or already higher, greater than 3. This is 4. If this is greater than 3, for these values of x, it would fall now on the third line. Okay? Greater than 3. So if you have 4, when you substitute 4 here, this will be negative times 4. This is negative 4 plus 2. This is negative 2. And this is 5. This is negative 3. If this is 6, this is negative 4. And so on and so forth. Okay? So if you draw the graph, okay, so take note ha, your negative, your 3, 3 is the starting point for x on the for the third line, but 3 is already excluded. Okay, so let's start first at 4. Okay, so 4 is somewhere right here. So 4, negative 2, here, this point right here. And for 5, that is negative 3, okay, right here and here. Okay, and it will go on this way, there, forever. Take note ha, 3 is still included, so I bet 3 is negative 1. It's a hollow dot, okay, because it says that negative 3 is the starting point, but negative 3 is excluded. Okay, so your graph would look like this. Yan. Hollow, solid. This is hollow. This is solid. This is hollow. Okay. So how do we define? How can we now define the domain and range of this function? Let's start first at domain. Ano ba yung domain? Take note, domain, again, paulit-ulit na lang, domain is the set of all permissible values of x. Okay. Now, when you look at x, at the x-axis, okay, kahit saang x ka pumili, there will be a point that intersects on that point. For example, if you choose this point, and if you draw a vertical line, okay, this vertical line is bound to intersect the graph of this one. Okay, Now, if you move this line from the left to the right here, it guarantees that this line will intersect at least once on any of these three graphs. Therefore, your domain is all real number, or that is from the negative infinity to the positive infinity. Okay, how about the range? How about the range? Okay, so the range naman, when you look at this one, for lower on quadrant 3 and quadrant 4, the highest value is this is -1, but -1 is excluded because this is not a solid dot. This is just a hollow dot. Okay, so meaning, okay, we'll define range. This is y. We'll use set builder notation. Y such that y is all real number and y is also less than lang, walang equal, because this one is not a solid dot. That's just a hollow dot. So less than lang, less than -1, and y is also equal to, we also have here kasi this is 1, 2, 3, 4. Yan. Now this is your range of the function. So y is all real number, y is less than -1, and also y is equal to 4. Okay, that is your domain and range of this piecewise function. Let's have the next one. We have here the signum function. Okay, let us have an example. Okay, suppose we have y is equal to the signum of x, abbreviated as is gn. So we have y is equal to signum of x. Okay, so for this type of equation, we can write this equation in terms of a piecewise function. And it says here that the value of the signum function is equal to -1 if your x, take note, x is whatever is inside on the signum notation. So whatever is inside on the signum notation, that's the value of x. So for x less than equal to 0, the value of the signum function is -1. Now for x is equal to 0, the value of the signum function is equal to 0, and for x is greater than 0, the value of x is +1. Now if you draw this graph, it would look like this. Yan. Okay. So, ibig sabihin, for x less than 0, so for the negative integer, the value for y, the value of the signum function, yes, the value for y or the signum function is -1. That's why your graph here, tipakadto. Take note, this is a hollow dot. This is not a solid dot. That is because we used the less than to 0. If this is less than or equal to 0, then this will be a solid dot. Okay, but since it is not, then this is a hollow dot. Okay, now for x equal to 0, your value for x, your value of the signum function is 0. That's why you have here a solid dot at the origin. Okay, the same with this line here. Okay, so if we try to find the domain for the domain, so what is the domain of this of this function? So your domain, since if you look at the graph, all values of x from the negative infinity to the positive infinity will be covered by the graph of the function. Then your domain is also all real number, x such that x is all real number. How about the range? Okay, there are only 3 values for the range. That is 1, 0, and -1. So your range will be, you can put it like this: 1, 0, -1. Yan. This is your range. Okay. Now, how about if we have this one? Signum x plus 1. Okay. Take note, ha? Sabi, oops, this should be signum x plus 1. The value of the signum function daw is -1 if your whatever is inside the signum notation, that is x plus 1 daw, is less than 0. And this is 0. The value of the signum function is 0 if your x plus 1 is equal to 0. And this is 1 if your x plus 1 is greater than 0. Now you have to simplify this one. So this will be, we just copy. So this is -1, 0, and 1. Great. Okay. So you have your x plus 1 less than 0, or I can rewrite it as x less than -1. Okay? I just transferred 1 to the right. Okay, and this one right here, I could write it as x equal to -1. And this one right here, this is x greater than -1. Yan. This is our new function. Okay, so for x less than -1, this is -1. For x less than -1, so that is from -1 to the right, the value for your function is -1. So here. So take note this is a hollow dot. So there. Yan. And when x is equal to -1, the value of your function is 0 right here. Solid naman. And when your x is greater than -1, so from the -1 to the right, your value for the signum function is 1. So right here. Of course, hollow. Yan. Okay. So this is your graph for the signum function. Okay, so the domain naman, the domain, of course, is all real number from the -infinity to the positive infinity. Yan. And the range is, there are only 3 values for the range. That is 1, -1, and 0. So you could write it as -1, 0, and 1. Yan. So this is your domain and range of this type of function. Okay, so these are the special types of algebraic function. Again, we have the constant function, the identity function, the absolute value function, the greatest integer value function, the piecewise function, and of course, the signum function. Thank you for watching.